Okay, so now we're back and we're going to actually implement our unit test. Let's get into it. Six point two JUnit. Let's get into the curriculum. JUnit is a library that provides the classes, methods, and assertions for writing and executing unit tests in Java. In this course, we use JUnit 4. Although there are newer versions now available, JUnit 4 is still popular and widely used. 6.2.1 Java Annotations. On the topic of unit testing, the annotations @test is used to indicate that a public void method should be treated as a test case. In Java, annotations are formalized bits of information about a program. They operate somewhere between actual code syntax and a comment on the code. Annotations do not directly affect the code they annotate, but they do supply information to the computer. Annotations are indicated with an @ symbol. We will provide an example in the walkthrough below. 6.2.2.jar and testing setup. In your Java web application, or Java web dev exercise repo, we included two .jar files for the JUnit library. These are located in the lib folder. JAR stands for Java Archive and is a common Java file format used for bundling many classes and files together. The JUnit library code is bundled and packaged in both the JUnit-413 beta-3.jar and hamcrest-core.1.3.jar files. Note, the versions of these packages may change before this text. In this project, we call these external libraries, or libraries dependencies. A dependency is a separately developed program or piece of code that another program or piece of code uses to carry it out its functions. Our Java tests will depend on JUnit code. In the future, as you build your own Java projects, you will likely include these dependencies in a different fashion other than .jar files. Many Java projects use a build automation tool to help manage dependencies. We'll begin using this kind of tool later in this course. Since we're not quite there yet, we've included the .jar files. Right-click on each of the .jar files. Okay, so let's do this first. Let's open up the IntelliJ. And I'm going to put these side by side. So let me do this. And so I'm going to open up the Java exercise here. Let me get rid of this for a second. And over here, it tells us to go down to the, let's look at the this one right here, the test. I think that's the one we want. So here we go. Let's read. In this project, we call these external libraries dependencies. A dependency is a separately developed program or piece of code that another program or piece of code uses to carry it out its functions. Our Java test will depend on JUnit code. In the future, as you build your own Java projects, you will likely include these dependencies in different fashions other than a jar file. Many Java projects use a build annotation tool to help manage dependencies. We'll begin using this kind of tool later in the course. Since we're not quite there yet, we'll include the jar file. Right-click on each of the jar files and select and add a library option to the dialog box. That opens up. Make sure the Java Web Dev Exercise project is selected, then clicked. Okay, so we want to do this one right here. That's the impl. So I'm in the project. We're already in it. So let's go over here, and it wants me to be in the project. So we want to right-click on the project. And then it wants us to go down to add a library. Okay, right-click on each of the jar files and select add a new library. So let's go over here to the lib. All right, so I'm going to click on this, right-click, and then it says add as library. So let's click on that. And then it shows us right here, add to module. It's already inside the drop down for us. And then add it as a library. So as we click, hit OK, and then that should be done. So make sure you're in the lib folder and then go to each one of the libraries, right click, the second one, Hamcrest, and we're going to add as library, and then we hit OK. Now, as you can see, they both are added. They have drop downs. Now we're ready to go forward. 6.2.2.1, main car and test car test. Within org.launchcode.java.demos, open the 1s5 unit testing directory, which is this one right here. I already have it open. And then it says you'll see a main directory and test directory. Open the car class within the main. So I'm going to go here to main, drop down, and here's my car class. Let me open that up. Let me make this a little bit smaller so we can kind of see what's going on here. Okay, so we have the car class. Have that open. Now, within the main class, look around. Here we provide a class car with the basic information about a make, model, gas level, and mileage, as well as getters, setters, and a few other methods, as you can see here inside the file. In the same directory, you'll find a main class with a main method that prints the make and model of a given car object. Run this class to verify that it works. All right. And so it tells me to go over to, let's look at this again, in the same directory, you'll find a main class. So we got to go to the main class. Let me open this up. Here's the main class right here. And then we're going to go ahead and run it to make sure it's working. All right, it's building. I'm going to let it build. So it's checking the source. So I'm actually running the whole entire class. So it's going through the whole main. Now let's read a little bit further while it's doing its thing. Now in the same directory, you'll find the main class with the main method that prints the make and the model of a given car object. Run this class to verify that it works. Make sure it's working. Yep, so it came back Prius. Now open the test car test. It's empty. Save for a few to-dos. Let's tackle the first to-do to make a new empty test. Starting with an empty test, let's use to validate that we can use JUnit in our current environment. So here we go. There we go. We got the to-do. Let me kind of make this a little bit smaller for right now, bigger so you can see. Now, it tells us here in 6.2.3, at test, create the following empty test underneath the first to-do. As usual, be sure to write this code rather than copy and paste. Okay, that's our instructions. So here's my first to do right here. I'm going to hit enter. And then under the first to do, I'm going to use my annotation. Hit enter. And then I'm going to use a public void. And then I'm going to call listen empty. Test. Don't forget, this is a method. Then we have our object to put in it. Now this is where we're going to use the assert equals. And then we're going to pass in some numbers. Okay. Once written, you likely need to add these import statements at the top of the file. Now, so I can save some time and you don't have to suffer through me typing this. Let's go up here and let's add those imports. So now we have those imports for the assert equal. And then we already have the JUNIT test, so we don't need that one there. So we have these two imports. Now note, in some cases, IntelliJ may sense which testing library and method you want to use and add the import statement as you type. If this is the case, just make sure they are the correct paths. Aren't IDs wonderful? Okay, so we have the path, we have our package up there, we have our imports, so we are good to go. Now, as we mentioned above, at test annotations, the method to signal it as a test case, we need to add the appropriate import statements in order to take advantage of these annotations. Our empty test is aptly named empty test, a description of its role. This test does not follow the AAA rule from our testing best practice, as it jumps straight to asserting, nor is it relevant for that matter. Again, the IDE comes in handy, inserting the names of each of our parameters expected. As you can see, these are highlighted right here: expected, actual, and delta. These are actually not there. It's just annotating. It's just popping it in for us. So here, expected, actual, and delta. This empty test is simply asserting an expected value of 10 to equal an actual value of 10 with an accepted .001 variance. Note, the third argument, called delta, is the amount of allowed differences between the expected and actual values. If the difference between the two values is within that range, then the test will still pass. This argument is optional for such comparisons and required for others. One scenario is which it is required is when comparing doubles. Why is it required? Well, that's kind of a long story. Some number types are floating point numbers. Here's a link. I want you to go check that out. Do some research. Due to the nature of this storage, these types carry with them a certain degree of inaccuracies. Make sure you click and check out the documentation on this as well. In brief, the delta argument assures we can still reasonably compare two doubles. Of course, 10 equals 10, but let's run it to show we know our test works. So I'm going to just click on this, run it. All right, our test finished. It passes because I got green check marks. Now, Click the green arrow to the left of public class car test to run the test. We just did that. Once run, you'll see a new output panel with green check marks indicating that the test passed and a message starting the test passed. We know now that the test runner behaves when a test passes and begin the real work of unit testing the car class. Under your second to do, write a test to verify that the constructor sets the gas tank level property. Now again, we want you to type this out, but to spare you the agony of watching me type, I'm going to paste it in, but we want you to type it out so you can get familiar with the syntax. Now here we give the test a descriptive name, test initial gas tank, initializing a new car object, and test that the constructor correctly handles the gas tank level properties. By now, you've probably already imported the car class. Here we go. Import. Let's look up there. Is it imported, the car class? I don't see it up there, so nope. So let's go ahead and import that. All right, so the car class is imported. No more red errors. Run the car test to see that both tests pass. So what I'm going to do, I'm going to run the main class, car test, and they both passed. If you want to run only one test, click the green arrow next to the test method name. So we can run each one individually by just clicking on the arrow or the triangle that's next to each one of the tests. 6.2.4, add before. The add before is another annotation we can use to help in test cases. The add before annotation can be used to set up some data or a condition that you want to have for every test in a given class. In the case of the car test, it would be nice to not need to create a new car instance for each test we write. In your test initial gas tank method, let's remove the line initiating test underscore car, and above that, your first test, add the following before method. So here on line 16, what I'm going to do, following the instructions, I'm going to delete that. And then I'm going to copy and paste this. I would rather you type it out, but I'm going to copy and paste it so I can, again, save you the agony. And then I'm going to come to the top of my test, and then I'm going to paste in that before. Now notice that it's in red. So what I'm going to do is click on it, and then it gives me a shortcut. If I do Alt Enter, it says import class. Now the class has been imported for me. Now notice here, I create the car variable right here, or object, test underscore car. And now I'm able to use this test underscore car with the create car object. Now, if I go ahead and I run this, this should still pass. There, it passed. And that's what we want to see, right? Now, IntelliJ didn't import it for us, so I did the shortcut by clicking on it, and it gave me the option to import it. Now we ran it and everything passed. So now let's get to 6.2.5. Now let's use the after. The after conversely defines a set of conditions to be met after each test in a suite is run. Note, a good or frequent use case for after annotation would be if you needed to test some code that requires access to a database. Here you could open the database connection with a @before annotation method and close the connection in an @after method annotation. 6.2.6 Common assertion methods. In addition to the above commonly used assert equals method, You see above, here are a few other methods you should have in your unit test playbook. Here we go. We're going to be using assert equals. It has the expect, the actual, and the optional delta, that third parameter or argument. And here's the descriptions of each one. Now, you want to get familiar with these and you want to play around with these. Also, do some research. Take some time to do some research. Now, we made it to the end of 6.2 talking about JUnit. So check your understanding and then go back over these two sections and get an understanding. Now, remember, the more you practice, the more you improve. Okay? See you in the next video and do the exercises. Take care.